protocol helps specifically to communicate in between the middle, that is like an that is in between the bridge, the middle layer, and the bottom layer. So this, which is like a communication protocol in this SDN architecture, means enabled the SDN controller to directly interact the forwarding plane of network devices. Such networking device, as I mentioned, in the bottom layer, which is like an switches, routes, or else like an both physical or virtual devices. It can be better adapt to change the some business requirements as well. So here, coming back to the again my previous slide. So this SDN controller, which will be acts as like a brain of the SDN network. So as which is existing in the control layer, which is in the bridge of the SDN infrastructure. The brain, which is the SDN controller, relaying information to the switcher routes, whatever that is with respect to the southbound APIs. The southbound means that is the part, the communication between the control layer and the infrastructure layer. So the application, that's what the communication with respect to the switcher routes, and also like with respect to the applications of a business logics, with respect to the top layer application, that is like a northbound APIs. This SDN controllers also have been like tasked to do some more additional features. It's like federating between the SDN controller domains, using some applications that's like we call it as like an OVSBD. So OVSBD, it is Open Virtual Switch Database for the data storage, and the OpenFlow for sure for the communications in between the two layers. So yeah, I was talking about an OpenFlow. So OpenFlow is like as I mentioned, which is an controller communication which switch over the secure channel. And this OpenFlow protocol defines the message format, what is the data format to be there for the communication between the networks, and also logic to execute it at the controller level. It has to be there. This have like with respect to the programmability, that it has some benefits. It is like enabling the innovation or differentiation, accelerating new features and service introductions. Even the centralized intelligence means like simplifying the provisioning. It is like if provisioning means it is like there is an existing network. If I want to onboard a new network to that a new device to the network, so the device which is getting added to the existing network need to be provisioned, means it need to be verified, qualified, validated. So it means either it's an right device to get added to the network, or else it has to be declined. So is it the right device to provide the permissions, or else is it the right device to share the information, or else it has to be declined. So these things will be verified by provisioning the device specifically, and allowing the device to enter to the network. That will be very well simplified with the provisioning mechanism. And the performance optimization also has to be very good. That is like an performance wise, the speed, reliability, scalability, and all. And some of the policy, and it has to obviously it has to follow with the specifically like some policy managements as well. So yeah, so OpenFlow, which actually it is like an defined. I'm not sorry, I've not included much more in the slides. Open Network Foundation is the one. It is like an defined this OpenFlow and is broadly accepted the SCDN protocol for the southbound interface. Southbound interface means again it is the communication between the middle layer and the bottom layer. So with this it OpenFlow, the forwarding plane of the network devices can be directly accessed, and also it can be directly manipulated here. And here OpenFlow uses the concept of flows. It is mainly to identify as I mentioned, the network traffic based upon like predefined match rules here. And here flows can be like an it can be like an, it's not supposed to be like an static all the time, because network we can't predict, right? So it has to be like an dynamically. So this open flow will allow us to program like an, either it can be a statically or it can be like a dynamically with an SDN control interface. The SDN control interface is the uh, which we see like an as a brain of the SDN architecture. And yeah, and the open flow is like an implemented in not only in the one side of the interface. So the overall, so because I mentioned like a southbound is where the communication in between the controller layer and the infrastructure layer. So as well as this protocol, open flow protocol, is implemented on both the sides of the interfaces, like in between the controller and the network devices as well. That includes for the northbound as well. And this controller manages the switch via like an open flow switch protocol. That is the one more open switch protocol that we have discussed. And the controller can also have an additional feature like an add, update, or else like an delete. So if there is any, for example, I just mentioned there is an onboarding of a device and device provisioning to the network. So if the device is provisioned, so for sure the device will be assigned with a new IP address, and the device will be get configured with an unique dynamically assigned IP or statically assigned IP address, and that route to be added to the network in that network. So this controller, which is the brain, which can in this one we can add, or as we can update, or as can delete the flow entries in the flow table. And here each flow entries in this case will contains the some specifically the terms like in match fields, counters, and also like an instructions to apply the matching packets and all. Yeah. Yeah. So another thing is like I just want to mention is like an network function virtualization will be get created here. So that we call it is like an NFV. So NFV is like an technology. I have not mentioned here. Just I wanted to point out for that specifically as well. I was just checking the same NFV. Did not included in the slide though. So NFV is like a technology that leverages like virtualization and consolidate the heterogeneous network. It's not yeah, and in the consolidation of the heterogeneous networks devices onto like an industry standard, like with a huge volume server switches and the storages. In this network functional, the function virtualization is like an complementary to the SDN, as NFV can provide the infrastructure on which SDN can run actually. Here, NFV and SDN are mutually beneficial to be. But this mutually beneficial means it's not like and both are dependent on one another. It's not like as if I mentioned SDN. I mean NFV is like in complementary as what I mentioned. Yeah, NFV can provide the infrastructure to the SDN, means it's not like and both are dependent. These are mutually beneficial, though these are like and completely and work independent, means each other. And this network functions can be virtualized without SDN. Similarly, like an SDN can run without NFV. That's what I mean. But this leverages the virtualization, consolidate the heterogeneous network and into the industry standards. With where in industry standards means like and where huge servers, where a huge large number of switches and where large number of storage devices will be taken care of. So this NFV architecture, my bad. I think I'm not, while transferring the file, I missed the slides. So I'm just sticking to this one. I will just give the brief overview of that as well, NFV architecture. So in this virtual network function, what I am talking about the NFV, there is an in this one. So the architecture actually consists like an management and orchestration, same like an SDN, and this will support for a virtual compute, virtual network, and the virtual storage. These three things, because it has like in three separate pillars: the compute, network, and the storage. In this we can create the separate like an virtual computes. We can come up with a virtual network. We can come up with a virtual storages. So these three pillars can be completely handled with an NFV management and orchestration. So if it is like an as I mentioned, virtualized network function means it is like an software implementation completely, though it's not an hardware part. So this software implementation of a network function, which is like an capable of running over the NFV infrastructure, that we'll call it like an NFVI. So that is the completely virtual based one, and also NFVI infrastructure means it includes the compute, storage, and the network resources that are virtualized. I'm telling there is an NFV management or orchestration. This management orchestration focus on all the virtualization specific management tasks. So, and cover some kind of an orchestration and lifecycle management of a physical or software resources that supports like an infrastructure virtualization or as like an lifecycle management virtualization and all. And also this like an NFV comprises the network functions implemented that run virtual resources in the cloud. And this enables separation of network functions, which are like an implemented in the software from the underlying the hardware. And this like an in this NFV, which actually enables the separation of a network functions. Yeah, so this provides a network functions can be easily tested. This is which very much important there. We can perform the easily testing of those, and we can upgrade it by installing a new software while the hardware remains the same. But in the case there is a different, sometimes there is a requirement of an hardware changes, but in this case the hardware we can return back the same, and we can make use of the upgrading the with respect to new softwares. And yeah, OpenFlow switch actually, and two more things I need to mention here is like an OpenFlow switch and the OpenFlow controllers. They are like a variety of OpenFlow controllers are there. So just to I would like to add a few more points with respect to the switch and the controller. So in this open switch controller, which contain like an one or more, I already mentioned there will be an flow tables that implement like an packet lookups to add, delete, or as like an insert new list in the table. In this switch contain like an one or more flow tables that implement packet lookups and forwarding, and also in this open flow channel linked to an external collector. I mean, the switch interconnects with the controller, and the controller actually directs to the switching using the open flow protocol. It is like same the process, though where a controller allows us to perform entries, perform like an as add or update or delete entries in flow tables existing in the switch, both reactively, that is in response to the packet, or proactively using the open flow protocol that can be performed. And this open flow controller is like an makes the decision based upon the policy set by the administrator. So where the network administrator sets, there are some kind of policies. It means where the term I'm using the policy, it is specifically for the rules, the network rules. So open flow controllers is mainly run on the rules, specific rules. So that's where the decisions also completely depends upon those specific policies set by the administrator. And here those decisions depends upon the condition of the network, because the network won't remain same. Some networks are like very small, some networks are like a very huge traffic, and some networks the interference could be very high, and most of some networks will be very completely wireless based networks, and some are within wired ones. It completely the condition, it depends upon the condition of the network, and their decision it takes is like an forwarded to the flow table entry, of all the switches in that specific network actually. And there are like two types of controls will come here. It is like an centralized control and the distributed control. So it's like a distributed control platform for large scale production networks. Because the centralized one will be like an over loaded with if it is like an if it consisting like an huge network based upon the data, huge data, the load which will push up on the centralized one. So to avoid that one, the distributed architecture, distributed control will support here. And so just I will just only mention a few of the advantages as well and the disadvantages what we can see here in the SDN. Yeah. If it is like an where I'm seeing in Dell, so there is a lot of options, a lot of reasons behind to move to an SDN. So SDN is like specifically with respect to the advantages. So for sure, as initially I was mentioning about the limitations. What are the limitations we are facing in the existing network from the so many decades? So in that case, for sure, to overcome those limitations, we are seeing some of the advantages here in this operating system. That's for the SDNs to move to this existing one to this one to the SDN. So advantages could be like an for sure we will look into the performance, the very important one. So we have like and we will get a like a very improved performance in the SDN and the innovation with emerging the technologies, the protocols, as I mentioned, in the existing network, the day-to-day, like a lot more and more protocols are coming up. The standardizations are coming up in the protocols, and we are just looking into the much and more open source instead of going with the industries are going with proprietary standards for their own, but we're even looking for the globally for implementation, looking for the open source protocols, and we are trying to encouraging that innovations. This SDN will provide a lot of benefits over the encourage of the innovations. That is what the major innovations like an emerging protocols and the standards, and also the scalability. And as like I spoke about configurations as well. So configurations is like most of depends upon the network. As I mentioned before, it could be like a small network, big network, large network, or as like based upon the data traffic which will be flowing over in the network. So the configurations will be completely an automated one. And the device flexibility will also plays a major role. It's not supposed to goes down. The network not supposed to go down when there's a huge traffic flow in the network. So this provides an high flexibility in that case, and also management is very simple. Obviously, with an user interface to management, with providing the specific rules. It could be like a centralized or as like a decentralized one, and the configurations and all. So, and also the price wise, if we look into the previous network architecture, the architecture depends upon the hardware, the network architecture, which relates, which completely where more and more hardware depends upon the software's integration, the software utilization. So in this case, which is like the price was also like an acceptable, which is lower cost. Some these are like an advantages, though I won't tell here it's completely an advantages. There will be as for sure disadvantages we can see in the SDN as well. So this SDN is like a single point of failure. I mean, if it is like a single point failure, or and if I can tell like a point of attack. If you attack, although the security is very much important here, and the security is very protocols are very good. If it's able to crack, in that case, this will be looks like a single point failure in the attacks here. So if I'm telling about the attacks, some threats also obviously I need to mention here. The threats could be like DDoS. There is like an distributed denial of service attacks, and yeah, data diversion, memory scrapping, and data forging, and like an identity spoofing. So these are like some of the network threats we can see over. Yeah, these are much more like an SDN, OpenFlow, and all that and NFV just overall. In like an eye level, if we want to tell here, as like an SDN is the like an major like a main component to provide the faster and more retail based upon in the upcoming like an 5G networks are coming up. In case like a 5G network will contain lots of devices, applications, and technologies, so SDN will enhance that configuration. So, and it can optimize and performances as well, and the scalability, reliability, and all will be has to be considered. And one more thing is like it will provide a real-time control to the network based on the network status, and in that based upon the information, based upon the data it has collected by its layer. So it will provide like a real time. It's not like there will be a lag. It's not like there will be a downtime or else like it's not like a downtime is that need to be reconfigured. It's not like that need to be reconfigured and to bring up the network. It's like completely an autonomous based one. Yeah. And yeah, we discussed about this one. Okay, some like an just to those who are if interested to go with an SDN to get started with just since we have some more time, I would like to just orally give you some where you can get kickstart like an see if it is like an environments for this SDN. Could be like some of the environments like Cisco have like one of the environments like Cisco and open. It's called like an OpenPK. OpenPK is like a one platform kit. That's it. And the Cisco one is like an Cisco Open Network Environment. It is like an as we are used like an it's a compressive solution that allows network to become more open, programmable, and application aware as same. And it's like a protocol complementary of multiple technologies, which includes the same things. That is also based upon the SDK, this specific SD1. Here it is like an same includes like a platform APIs, agent technologies, overlay network technologies, the controllers and all. This platform APIs are like a key element within the single strategy and a part of this development kit. The development kit, what you call like an OpenPK. So I mean the open platform kit, that's OpenPK is a short term. It's like a set of platforms as platform APIs are available. It will provide like a full duplex programmability access to the Cisco device in the network. Those who are in the network field, for sure you played with a Cisco device, it will be even more familiar, easier to play with this kit, open platform kit. And it is like which allows developers to build custom applications on that one, and also that to interact with Cisco network devices, which is an easier one in ways that may have never before seen like some stuff. And this kit enables developers to build automation and orchestration in that network. And that PK is a good one. Just and with if the developers are here, so we can ask like what kind of programming or as like an API integrations are supported. So just Cisco is not promoting anything. Sorry for that. I'm just with an experience I'm taking up here. So this architecture actually, OpenPK architecture is like an highly flexible development environment. It supports with an multiple programming languages. It is like we have used it with C, and some of my colleagues we have used it in Java. And yeah, Python is also like a very familiar language nowadays. So Python will also be supported in this basically. Okay, looks like I have some more time. I would like to take up the questions here. Yeah, this is what I wanted to present. I hope this get beneficial. So if there are any questions, I would like to take up those questions.
Okay. This sir, can I unmute the participant so that you can take up the questions?
Yeah, sure, please.
Okay, you can unmute yourself. Any doubts, you can get it clarified with the speaker. The session is open now for discussion. Okay. Other sir,
Yeah.
no questions put up on the chat box either.
Okay.
Shall we conclude?
Okay, sure. Thanks for this opportunity. If there are any queries would like to take offline anytime, the mail ID is shown on the slide, so can reach out to me.
Okay. I would like to express our sincere thanks to Mr. Adarsh for taking his time out and giving a lecture on software-defined networking. Thank you very much, sir. We look forward for more of interaction with you in the days to come.
Thank you so much.
For the participant, I'm sharing the link for the third session. Please take time in filling up the feedback for link 3, session 3, I'm sorry. Okay, as dear participant, as you are all aware, we have just finished the last session on the day 1. Tomorrow at 10 a.m. we'll have sessions for the day 2, beginning with mobile phone investigations by Vibhu Anand, and then following it up with vulnerability assessment and exploitation by Viral Farmer. In the afternoon, we shall have 2 more sessions, scanning the network using free and open source tools by Dinakar, and scanning the network using free and open source tools by Ramji. Looking forward for a profitable day ahead. With all this, I wish you all the best and thank you for attending day's 1 session. The meeting will be closed in another 5 minutes. During that time, I request all of you to fill up the feedback forms across all the 3 sessions. As of now, session 3 feedback has been posted in the chat box. Okay, I think Dr. Lakshmi, Madam is asking few questions. Madam, can you unmute yourself and then talk? You're asking about the tests being conducted.
Yes, sir. Actually, just asking tests are there daily. It is told to us.
Okay, I think as far as the instruction we have it, we need to conduct few tests and we'll do that.
Okay.
If not on the first day, we'll try
Okay.
to pick up
Thank
any
you.
days to come. And as far as the attendance is concerned, you have to log in to the portal to generate the attendance status. No separate link will be generated. And that is the, as per the instruction of AICTE, we are doing that. And in fact, that is the reason why we are closing the portal or meeting portal at the end of every session so that a report gets generated.
Excuse me, sir.
Yes, sir.
Sir, actually, I have joined as a guest. I'm not able to find any attendance portal, sir.
No, attendance portal is not there.
Yes, sir.
For every login, the status will be generated automatically. If not as a participant, at least you will be listed under guest.
Okay, sir. Thank you, sir.
There's a lot of problem in login.